Including design experience in your ECSA application may not be enough to get you ECSA registered. Keep watching to find out what I mean. Hey, Mike Young here, and in this video we are going to discuss how telling ECSA that you have design experience may get your application denied. And if you stay to the end of this video, you'll discover what ECSA is looking for when it comes to design experience and how including certain designs can get your application put in abeyance. So what does all of this mean? Well, let's start from the very beginning. If we go to ECSA's website and go to the documents section and scroll down to the category in which you're registered in, I'm going to use professional engineer as an example. And if we click on document R08, the following will open. If we now search for the word design, we will eventually come to overview of outcomes, which is also referred to as table 1 in this document, and you will now see these words, design or develop a solution. Now this is the point where you need to be very careful. I would like to know, how do you understand the words design or develop a solution? If I was ECSA and I asked you to tell me about an experience where you designed or developed a solution in the past few years, what answer would you give me? Would you proceed to tell me about a specific project that you spent years working on? Would you tell me that you designed a system that comprises of many different components? Or would you describe a solution that you developed that uses lots of principles of maths and physics? Now, before you tell me your answer, I'd like to quickly go back to ECSA's document and show you something that is overlooked, which can often result in your application being denied. In this document, it says design and develop a solution to a complex engineering problem. The last three words, complex engineering problem, is the game changer, and I'd like to spend some time talking about these three words. If I was ECSA and asked you to demonstrate that you developed a solution to a complex engineering problem, what answer would you give me? How would you convince me that the problem that you are solving is indeed complex in nature? Would you tell me that it's complicated because you applied engineering principles, or would you tell me that it's complicated because it was a large-scale project? Notice how the scenarios begin to change by adding in the words complex problem. Now, while it may seem silly that I'm putting so much emphasis on the problem being complex, I'd like to show you a letter that a candidate sent me after they submitted their application for professional review. If we look at this letter, one of the reasons why this candidate's application was put in abeyance was because outcome 1, 2, and 3 was not demonstrated, and the candidate was unable to demonstrate competence in complex engineering problem solving. So, what is a complex problem? Now, each of us have our own viewpoint of what is a complex problem. And for your application to be successful, you need to ensure that your definition of complex problem is identical to ECSA's definition of a complex problem. So, what's ECSA's definition of a complex problem? According to ECSA, a complex problem is one that involves engineering first principles. It involves developing a solution that falls outside the scope of standards, and it's a problem that requires the use of engineering judgment. So, what does all of this mean? Let's take a look at the first requirement. According to ECSA, if you do not apply engineering knowledge and first principles of maths and physics, the problem is not viewed as complex. So, why is this the case? Well, let's take one step back and see it from ECSA's viewpoint. Would you agree with me that technology like the cell phone is constantly evolving and improving? The next cell phone model will have a better camera. It will have more memory and a faster processor that will handle all these new and improved apps. Now, would you also agree with me that all the components such as a microprocessor, the memory card, the camera, and software all work together to make the phone function? And would you agree with me that the development on all these components can still be related back to the principles of maths and physics? Not convinced? Let's watch a short video to see how a computer processor works and how it's used in the development of a cell phone and how first principles are used.
CPUs, or central processing units, are single-chip digital machines for executing a sequence of instructions called a program. CPUs are mainly built from millions or billions of miniature transistors, but to understand their operation, it's best to focus on their internal structure or architecture. Today, most CPUs form part of a von Neumann architecture. This includes a control unit that coordinates the processor's activities, as well as an arithmetic logic unit that performs mathematical and logical operations. As we're about to see, CPUs in the von Neumann architecture need to constantly exchange data with a computer's memory, whilst also interacting with input and output peripherals.
Notice how everything comes back to basic components such as transistors, and the actual logic that makes a cell phone still comes back down to mathematical operations. So when it comes down to ECSA, they want to see how do you understand all the basic principles that you obtain from your undergrad qualification, and more importantly, how are you applying these principles in the correct way to yield a solution that works. So here's a question that might be on your mind for some of you who are watching this video. Some of you might be thinking, what happens if I haven't applied first principles from my undergrad qualification? Will my application still be seen as not competent? Well, let's be honest. Most of us who work in the industry use computer programs and software to help us complete our designs. So if we use computer programs, is the problem still seen as complex? Well, for mechanical engineers, it is not recommended to use computer programs when demonstrating outcome 1, 2, and 3. For the other branches, it's taken on a case-by-case basis, and should you choose to include the use of a computer program within your report, just be prepared to provide ECSA with an answer should they ask you this question. How have you solved a complex problem as a computer program that you used in your design did the entire analysis for you? Now, if you are in this situation where your work experiences uses a computer program in your design, or you are in a facilities or maintenance role where you do not have complex design experience and need some guidance, go ahead and scroll down to the description box below, click on the link, set up an appointment with me, and we can provide guidance on how to overcome this obstacle. Let's now move on to point 2. Your solution must fall outside the scope of standards. So what does ECSA mean by this? Accordingly, some standards prescribe how to design certain systems as part of the standard. So let me ask, if all you did was follow each step as described by the standard and substituted number values, is this seen as a complicated task? When it comes down to a complex problem, rather proceed to perform your own analysis, develop your own solution, and use the standard as a check of your results rather than using the standard as the guideline. This now brings me to point 3. Engineering judgment needs to be demonstrated while you are developing your solution. Now, I've reviewed many candidates' reports, and some candidates state that by completing the design of a specific system, they have performed engineering judgment. So, what's wrong with doing this? Well, if I told you that I was Spider-Man, would you believe me? Probably not. But what if I said I was a half marathon runner and you physically ran with me 4 times a week and you completed a half marathon for me? Would you be convinced that I'm a runner? Notice the difference between telling and actually proving through demonstration. So this is the thing. When it comes to ECSA registration, there's a big difference between showing and telling. And unfortunately, the mistake some candidates make is that they tell ECSA that they are competent instead of showing them. So what is engineering judgment all about? Unfortunately, this topic requires its own individual video, so go ahead and switch on the notification button, hit the subscribe channel to this video, and you will be notified when this video will be released. Now remember, the goal is not to include design experience. The goal is to include the design experience of a problem that is complex in nature. It's experience that shows you how you solved a complex problem, and it's experience that requires the development of a complex solution with the use of all the knowledge that you gained in your undergraduate qualification. So, what's next? Well, go ahead, leave a comment in the box below on your biggest takeaway from this video, and if you need help on your complex engineering problem, be sure to click on the link below, schedule an appointment with us, and let's see how we can work together to help you solve this complex engineering challenge. This is Mike Young here, and I look forward to seeing you in our next video.